Cool. So today I wanted to talk about or just node file input and output. So I wanted to go through some examples of how to read and write content from files. And then we'll do like a little serialization. And then maybe we'll talk about standard in and standard out if we still have time. Let's get this a little bit bigger. All right. So let's touch our. So I think for an example, I'll use just like a little to-do list app that's just going to read and write to another file. It's something that you've seen in some of our modules before, and so I'm just going to run through an example of that. And then if you have any questions, we'll go from there. So I'm going to store all of the data for this in tasks.json. And if I'm going to access the file system in Node, I'm sure there's other ways to do it, but the easiest way to do it, or the standard way to do it, is to require the fs module. This is a built-in module to Node, and so it's well documented in Node's documentation. So let's take a look at that. I'll search for Node fs. And it's the file system module. And when you land on this page, you'll see that like it's just got a ton of stuff listed at the top. And so you'll become familiar with what these things mean as you spend more time modifying the file system. But what we're going to start off with is fs.readFile. And we're going to use readFile_sync. So this is the synchronous version of the more standard appropriate read file, and this is sort of how we use it. I don't know why it says directory, but we're gonna just to show you the errors that it gets. So we're gonna use readFile_sync to read the contents of our tasks.json file. So I need to know the path to that. So let's start there. In order to do anything on the file system, we need to know like how do we get to that file? How do we get to the path of that file? And so if we're in this terminal here, we can see like if we use pwd, we can see this is the directory that we're in. So if we wanted like the full absolute path to this file, we could do like pwd and then we could tack on like tasks.json. So I could come in here and copy this and say that my path to this file is like that. So this is one way to do it. I can literally just go statically put the full absolute path to a file in my script, but there's a couple of problems with this. The main one being that it only works on my computer. It only works on computers who have deadly icon as their username and where they've put this file exactly in this spot. So we want to dynamically figure out how to get to this file. So in order to get this absolute path to this file. So kind of like what I did here where I said, okay, what's the working directory? And then I'm going to say almost something like plus tasks.json, right? So you can do that in Node by getting access or by using this special variable called __dir_name. And so for right now, all my script is going to do, just to illustrate what this variable is I'll make my script just log that dir name. So I'll run node tasks.json. Node go away. Node to-do list. And it prints out the same thing that pwd prints out, because I have the directory that I'm in the terminal is the same directory that this file lives in, right? So that's what __dir name is going to give you. It's going to give you the full absolute system path to the directory for the current file. So since we know that the file that we want to read is in the same directory that we're in, we can use this to do something like this. We can say get the dir name and just add slash tasks.json. So if we log path now and run our script, we'll get that full path to the file. And I'm going to copy this and make sure that it works. So I'm going to run a command called file, which the command file just tells you tells you information about files. So this tells me this file exists. If I gave file a path to something that didn't exist, it would just say no such file or directory. But so I know this file is I know this path is the right path, and it tells me that this JSON file is empty, and that's true. So this is one way to to traverse sort of relatively from where your script lives to where some other file relative to it lives. And this one's easy. It's just the current directory that we're in plus a different file name. Okay. There's another way that you can build paths to get access to the absolute path to files, and Node offers you this library, which if I could type would be called path. So this is another library that we can look up by searching Node.js path, and it has a number of functions on it and methods on it that will help you do things related to finding and generating appropriate paths. The one we are going to use is resolve. And you should come in here and read through this, but the basic usage we're going to do is just basically glue two paths together. So /foo/bar plus ./baz will give you this. So you can think of this as if we cd'd into foo/bar, and then we were in that directory and we said, you know, cat./baz or something like that. That would basically mean, here, go ahead and do something to this file. This is the absolute path representation of where that file lives. Something like this would be a problem where this is an absolute path because it starts with a slash, and so is this. So you can't really glue two absolute paths together, right? Because this starts at the root of the file system. It does not live inside of here. So that's what resolve is meant to do, is to take different parts of a path, and depending on what they are, it's going to glue them together. So for example, this path has a .. at the beginning of it. That means that when we glue all these things together, we're going to get rid of the PNG, because this says go into PNG, then go back up one directory, which takes us back to static files, and then go GIFs image. So our ending results is static files GIF, and PNG is gone because the .. sort of went down to PNG and came back out again. Just like if we had cd'd into a directory and then cd ... right? It's kind of using that same sort of syntax, the .. the slash, and the .. to sort of glue things together. So if we want to make sure that this path is getting glued together correctly, we can say path.resolve dir name, and then get rid of this slash, and we should get the same result. It should say take the path for the current directory and then add this to the end of it. And so if we run our script again, oops, I'm going to give this path a capital P just so that, or maybe I'll just give this a better name. I'll call this tasks JSON file path. And just to make this easier to read, we'll do something like that. And we should get back not what I expected. Oh yeah, because I'm logging the wrong thing. There we go. So we do get back now. That's just like we glued it together by hand by adding one string to another. This is being a little smarter, and it's just going to glue things together. So for example, if I came in here and said .. that would resolve to, anyone want to take a guess what we're going to see different from this output? Yeah, so it'll be something like users, deadly icon, work, and then task.json. I think so, yeah. So the .. should take this directory out. We should go up one directory, and then we're actually going to go up two directories. So it should be users deadly icon work task.json. There we go. Cool. So just like if we had said cd ... right? That takes us into the work directory. So it's really that same mechanism there. Cool. So now that we have the path to our file, we want to start reading and writing to it. So for just to bootstrap our selves here, I'm going to go into task.json and I'm going to give it some JSON. I'm just going to write it in here by hand. Oh my god. Type. Cool. So there we go. So I added a little JSON. So now we should be able to read the contents of this file. So let's do SF, let's do file contents, and we'll do fs read file sync, and we're just going to give it that path. And then we're going to log the contents. No such, oh yeah, I forgot. This was just an example. Here's our real path. There we go. Okay, so it gave us back this buffer object. So what we would expect is we say, hey, go read that file, and then give me back, give me back the contents of that file. And in this case, this file, its contents is like a UTF-8 string. So I expected to get back a string, but I actually get back this buffer object. And the reason why there's this object in the middle is because sometimes we read files that are really, really big, and we don't have enough memory to open the whole file at once. So we need to like scan through the file sort of chunk by chunk. And so buffer is this object that allows you to say like, okay, give me the first few bytes, and then read and do something, and then empty your memory and read the next few bytes. And so we can do this sort of, we can make a script that only ever uses like 10 megs of memory at a time to slowly walk through a 10 gigabyte, you know, MP4 video file or something like that, right? So this buffer object would give us access to saying like, okay, read in chunks. But we don't need that. We're going to load the whole thing in memory. And so we're just going to tack on a toString at the end here. And what that's going to say is, okay, buffer, go fill up yourself with everything you can get from this file and then convert it to a string.
So is there any difference between doing the toString or giving read file sync the second argument that says UTF-8?
Let's find out. If we, there's the toString, and then if we give it the second argument, what is it, UTF-8 or something, or just 8? Like that? I don't, yeah, that's interesting. I didn't know that it would do that. Let's read the docs and see what they say about that, if there's any difference. So when you give it this optional encoding, I'm actually going to read about read file, because read file sync, it kind of wraps around read file. Let's see. If no encoding is specified, then the raw buffer is returned. Okay, so yeah, so you're right. So yeah, either calling toString on the buffer, or giving it a specific data type. So we'll say UTF-8 here. That's cool. I didn't know that. I've always been calling toString on it. I didn't realize if you gave it a encoding type that it would encode, that it would do that for you. So that's good observation. But we got what we expected to get out of this file. Yeah? Cool. So this actually is just a string, though, if we look at the type of what's coming out of here. It is just a string. But we want to convert this into like the actual data that is in this file, right? So we're going to do json.parse the file contents. And this will actually be our, I don't know, we'll call it tasks. Let's just call this state for now. And you should see a little bit of a different output here, where it kind of squished it all together here. But we did get back real data. We can do state.tasks and get the first task and just get its description. And so you can see we're actually using real JavaScript objects now that were built from that JSON and that file. Any questions on the steps we've gone through so far? No? Cool. Okay, so let's modify the object and then write it back to the file. So if we have state.tasks, and we're going to actually just push another task inside of this array, and so that looks like this. But we don't actually have to use JSON format here. We can just use JavaScript. And we will add another ID. We'll say it's false. And we'll just say, like, I don't know. And then we'll push another one in here. I don't know. Great. And so now if I log the state object, we'll see that these changes were made. We now have 3 tasks in our object. But if we look at the task.json file, we haven't written that to the file yet. So that's what we'll do here. We're going to say fs.write file sync. And we're going to write to the tasks JSON. What's up? Oh, thank you. We're going to write to this file. And we're going to give it some JSON, which we'll make. And does write file take an encoding? It does. And it defaults to UTF-8, so we'll just let it do its default. And let's see what happens. So if I run node list, and then I cat task.json, we can see that now my additional data has been added to that file. And if I run this more than once, the way we have it written, we're just going to keep adding like a bunch of duplicates now, which is not exactly what we want, but we can see now how we can take how we can read read data from a file, turn that data into actual objects, into actual JavaScript objects, modify those objects, and then turn them back into a JSON string and write them to the file.
What are those arguments in the JSON string file?
Yeah, these have to do with just how it outputs. So if I say JSON.string, and I give it an object with A1 and B2, it's going to give me a string where they're just kind of written as scrunched together as possible. I don't know what the second argument does, but the third argument is like how much. We can look it up, but I never use it. I don't know what it does. So I always just put null to sort of skip, because there's no way for me to give a third argument without giving a second argument, right? That's a limitation of how function arguments work. But if I give it a 2 as the third argument, you can see how it gives a new line and some spaces. So here, I'll make this easier to see by just wrapping it in a console log. Right, so it comes out like that, but if I give it null and then 2, it just sort of breaks things out into a multi-line with indentation. And normally I probably wouldn't do that in this case because I'm not really expecting anyone to actually look at this tasks.json file, so I wouldn't mind if it was all scrunched together, but for the purposes of making it easier for us to talk about, this is sort of a little bit of a beautification, but it's not relevant to the data. It makes the file size a little bit bigger, but it's not a big deal for what we're doing right now. Cool. So has everyone done an example of this before? Everyone read and write to a file before?
I did the exercises, but when I started doing that to-do list benchmark, I'm stuck. How we get those ID numbers? How does it know that it's the person? Like when we pass arguments to the task, we only give the description, right?
Sure.
But then when it goes to the JSON, it somehow should go with the ID.
Sure. So the JSON part of that, actually, you can kind of take that out of your equation when trying to figure out how to get proper IDs, right? Because that's really just like a data question, right? It's just how do we store things, right? So if we have this kind of shape where it's like a to-do list item where we need to know its description, we need to know whether it's complete or not, and it needs to have some unique identifier, right? We could store that all kinds of different ways, right? We could use an array, for example, and then I would just not have IDs on the objects themselves, and we could just consider each one of these items in this array to be uniquely identified by its position in the array, right? So this would be ID 0, and this one would be ID 1, and we could keep pushing things onto the array, and everything would get a new sequence, right? So that would be one way we could uniquely identify. And then if we had this as data or as an object here, then we could just say, get me tasks 0 or task 1 or task whatever, right? And so that's one way to store this, right? Another way would be we could come up with our own sequencing system, our own ID generation system, right? So let's say we store tasks as an object, and we just say the key here is 0, and the value of that is this task. So now this is kind of like an array where we might, but it's using keys and values instead. So we might store this as 1 or whatever. But we could also add other keys in here, like last ID or something was 1. And so now we know we have some other metadata in here where we can say, okay, if I need to create a new task, I'll say tasks bracket tasks dot last ID plus equals 1 equals this new task. And so what this is going to do, this is just an example. There's so many different ways to do this. But so for this, for example, it's going to say, okay, go get whatever numbers in here. In this case, it's 1. Add 1 to it. Actually change this thing. So we're going to increment our last ID. We're going to say it equals, this is the same as saying equals last ID plus 1, yeah? And then we will access our task object at that ID and give it our new task. And so now what will effectively happen is it's going to say, it's going to increment this to 2, and we're going to put that guy here. Right? So that's another way where we can say we've got some arbitrary number of things. Let's store some extra data saying like what was the most recent ID we used so that we can always, so even if we delete some of these, we're always going to be going up in the sequence of our IDs. But this is again irrelevant to our JSON and how we persist this. This is just how we deal with objects in JavaScript and the many ways that we can shape our data. So does that, do you see how you could apply that to the project you were working on?
Probably that first option when we push in the array, that would be more.
This is going to be really easy, yeah. The downside to this is if, the downside to this is if I go delete this and then I push another item into the array, we might end up with 2 items that have the same ID. And at least in that one to-do list exercise, like each to-do list item should be given a unique ID, and we should never have duplicates. So that's just one constraint on this problem. But if we didn't have that constraint, then an array would be great, right? There's also something nice about an array, which is that it's ordered, right? The object down here isn't guaranteed to be in any particular order. So we would have to order the to-do list items, and that's not a part of that challenge. But if we were creating a useful to-do list, we'd want to be able to put them in the order that we want to work on them, right? So we might want to use something like an ordered array here to store them in. But that's why these different data structures and shapes have different trade-offs and different different usefulness.
I had a related question about that. So I've been working on this project, and I had to wrap, like, I have a task array, and I have, but I have it wrapped in an object, because if you, am I understanding correctly that the JSON object that you're writing to always has to be an object, and that you can't have it as an array as the
You can.
thing?
No, you can have it be an array. I mean, I believe it would work. Let's try it just with this little script that we've written here. I'm just going to parse whatever's in that JSON file, and I'm going to treat it just like an array. So instead of having, just like you said in your project, you had an array that was nested under a thing. Yeah. If we move this to just being an array, and I'll just put another one in here for fun.
I don't know what I was doing. I was making a third error when I switched it to an object. It was like, I didn't know if I was doing something else.
All right, cool. So I'm just going to read the state and then treat it like an array, and then we'll see what happens here. Syntax error. So let's see. This came from line 12, which was when I tried to JSON parse the file contents. So it didn't like this because of this trailing comma. Yeah, there we go. Okay. So it does allow you to do, I think those are the, I think there are, I mean, and files, we can try this without worrying about files, right? So if I just go into Node and I say, let's create an object. It's an array of 1, 2, 3. So we'll just call it X, and I say JSON.stringify X. Stringify X. It turns it into, and then I can do JSON.parse kind of around that, and then we'll see like, okay, X is getting turned into a string, and then it's getting parsed. So we know arrays work. What if we gave it what if we just gave it 42? Looks like 42 can be turned into JSON and pulled back out correctly. What if we gave it an object of A1 and B2? That looks like it can go in and out of JSON. What if it was just a string? That'll work. And so you can kind of come in here and just ask the computer, like, if I turn it into JSON and then parse it, will it go in and out the same way?
Yeah, I see where I went wrong, because I saw that bracket as an error. I got the same exact error.
Yeah.
The ES linter for Airbnb wants you to put trailing commas in.
In your JSON?
It yells.
It's wrong. It's wrong.
Like, now I understand why I had that problem.
Yeah. Yeah. Yeah, those can be tricky because the error isn't coming from the JavaScript. The error technically is coming from some JavaScript you didn't write that's trying to parse some file that you did write, and it's not necessarily telling you like exactly what's going on. It's like somewhere around line 11, it got all messed up. Good luck. You know what I mean? And so really looking at those line numbers when those errors come up is where it's going to be really helpful to try to track things down. I also find that like if I'm in here and I've got this problem where it's like I can't read your file, unexpected token left bracket in JSON at 166. That's character 166. I have no idea what character 166 is. So sometimes I'll come in here and I'll just be like, and I'll just try to delete shit. And I'll be like, okay, does this work? An empty array. Okay, that works. If I put one thing in here, does that work? And it's like, okay, I get the same error. And so like, I'll just try to sort of poke around and delete things. And hopefully if we're using Git and we're committing all of our stuff frequently, it's pretty easy to just go into files and just delete shit and just do really aggressive changes to try to kind of debug what's going on.
your HDMI backend.
What's up?
Your HDMI backend.
Oh no. Thanks. I didn't notice.
It just happens.
Go. Source detect. There we go. Cool.
Yeah.
So using read file sync and write file sync makes it really simple for us to be able to read the contents of a file, do whatever we want with those contents, and then also write whatever contents we want back to a file. And so that should give you a lot of power to store state between your between one run and another run of your application, right? So this project is a really great project. There's a lot of rich things to learn about it, this to-do list thing, because that's almost all of application development and software development. We want to be thinking about what is the current state of things, and then how do we mutate state based on some action, right? So we add something to our to-do list. What does that do to our state object? We remove something or complete something. What are the operations that make those changes? And then when our application isn't running at all, what does the state look like in like this file or the database or whatever, right? So you're gonna have to, so that is worth really digging into and really getting to a place of comfortable understanding, because as we scale up to web applications, we're going to start thinking about not just a JSON file, but like tens or hundreds of tables in a database, and then not just one to-do list script being run when the user runs it, but like thousands of commands are being run from thousands of different browsers to probably 5 or 10 or 20 different app servers that are all connected to 1 or 2 or 5 SQL servers. So this complexity of this problem of like someone's taking an action and that needs to mutate our state. What does our state look like now and what should it look like next? That is scales up to really complex, really big levels of complexity, right? So if you were to go work at a Facebook, you're going to be modifying some state in some database at Facebook, but you're not going to understand every single other team and product and service that they offer. You're going to have to work alongside that. So things can get real complex really fast. So really digging into this transactional way of thinking of I'm at state A. When I take this action, I should be at state B. And that sort of deterministic transactional way of an application running, that's exactly how a web application is going to run. It's going to be a transaction when someone makes a web request, and that transaction is going to probably at least read state, if not read and mutate state.
So one more question.
Yeah.
On this. When I was first looking into how to do this project, when I was looking at like the various FS methods, I noticed that there was like an append file, and there was, and so in the beginning I was like, oh, wouldn't it make sense if I'm adding a task to like just append it to my JSON? And then, people were telling me like, no, you want to like read the whole thing and write it every time to make sure like all of the changes are going through.
Sure.
But is that like, I'm thinking like in terms of scaling, is reading the whole thing and writing the whole thing potentially more dangerous?
No. And this question is touching on a little bit of optimization, a little bit, like you said, like would this scale, for example, right? And I really don't think it's helpful to worry too much about scaling and performance. This is certainly in phases 1 and 2. I think it's much more beneficial to get down like the logic and the reliability of writing an application that's going to do what you expect every time the right way and is free of bugs and edge cases, much more than it's a little bit faster than it would have been, right? The way we're having you write this to-do list, if you were to actually use it for years and years, that file would get bigger and bigger and bigger, and it would eventually slowly slow down. Because every time we read in that file, it's going to take more memory to read in that file. It's going to take longer to read it. That file's going to get, if you used it every day and you're at it, and you're going through hundreds of to-do list items a day, right? We're talking about getting into gigabytes of data after a couple of years or something like that, right? But that performance is not something that we're that's ever going to really be a problem, right? You could always just go clear out that file or whatever, right? We do need to worry about performance when we start worrying about at-scale web applications. But that's going to be at a point where we as developers, like, we know we can build this feature and it's going to work reliably. Now that we have it, how do we do it in a way that's going to allow 1 million people to use it actively at any one time, right? Maybe we'll have to change our SQL queries. Maybe we'll have to use a different kind of database. There's an optimization that kind of, at least for now, I think should not come at all or come at the end.
Okay, yeah.
But your other question about, like, your intuition says if we're adding something, why don't we just use append? That way I don't have to read the file. It seems like it'd be more efficient. Unfortunately, with JSON as a file format, there's some exceptions to this, but you can't really just append. So append is great for things like a log file, where we just need to add stuff to the file and I don't care at all what's in there now. I actually don't even care if my thing goes in there in the right order as some other thing. I just need it in the file. Just stick it in there. So append is really good for that. But we could develop a state storage system for this same to-do list interface that used append, at least for the adding of a task.
So, like, if you wanted, like, a log of, like, every task you've ever put in there ever, regardless of whether or not you deleted it or completed it, like, that would be the use for that.
Sure. There's so many different ways to do this. One way, rather than storing what the current state of our application is, we could instead just store, it's crazy, we could instead just store a log of every action the user ever took. And then when we want to add a task or complete a task, that's just appending an action to a log file. And then we don't actually store our state. We just store all the activity that's ever happened. And then we can read that file and derive what the current state is by saying, like, okay, you added 3 things, you completed 1, and then you uncompleted another one, and then, like, build it all up, right? And that way, we're trading off the speed of writing, because we can just append. It's really fast. We don't have to read the file. Adding a task is super fast. But then reading what tasks are left to do and what order are they in, that gets more expensive because we now have to read this whole log file. And so a lot of the times when you find yourself asking the question, like, is this going to be faster? Is this going to be better? Is this a better solution? Is this the right solution? You should, if you ever feel yourself asking, is this the right or wrong solution? A better question is, how many solutions will work, and what are the trade-offs between those solutions? We could write this data to a file 100 different ways. There's probably only a few that would be fun for us to code, that would make sense for us to read and write and to reason about. And then there's even fewer of that set that I think would be the most optimal high-performance trade-off for how our app is used. And often we just don't know when we talk about optimization. So a lot of my web development and the web development that I've seen is we've got a feature that needs building. Let's build it. Let's get it to a point where it works. As we grow as developers, we're going to know how to avoid certain pitfalls of obviously this will never scale. Let's not even try to build it this way. But for now, let's just build stuff that works, test the edge cases, and then what we can do is when we have a feature that works, we can look at, we can sort of analyze how it's being used, right? So if I build like an upload photo image feature to a social networking site that I work for, right? So I build the feature that lets someone upload a photo, and that photo goes in our database, and then later other people can see those photos, right? What if viewing those photos happened 1,000 times more often than uploading a new photo, right? That tells us something about how we need to optimize where these photos are stored and how we need to make it so that it's very inexpensive to serve these photos, but it can be expensive to put them in and to upload them because that doesn't happen very often, right? But if we're talking about a different feature where it's like a backup photo service, no one's ever looking at these, they're just a backup service, then we want to optimize how we store, how quickly we can store those, and getting them back out. We can think about the trade-offs of where we store our data based on how it's being used in the real world, right? So the point being is that a lot of times optimization is left toward the end when we figure out how our services are actually being used, how our applications are actually being used. Cool. So we have a little bit of time left, so I'm going to talk about another input and output system that is available to you in Node and in all, really all sort of Unix, Linux, scripting languages and application languages have every program that you run in the terminal has 3 different pipes, basically. The analogy I like to use is sort of like a fax machine. But we have standard in, standard out, and standard error. And so what this is every script has a, you can think of these pipes as like a pipe that transfers data, but most of the time it's transferring text. So we can think of it as like a fax machine. So every script that you run has this optional stream me some information, and then every script has a standard out. This is actually the one that we're all most used to, or we're all most used to is the standard out. So if I do like ls, the text that came out here was sent to standard out. The standard output of the ls command is what it's supposed to do, is to list what's in these directories. So it writes to standard out. And I can take that data and I can send it to another program. So if I pipe it to grep and I say read, what this command is doing is it's saying, take the standard output that normally would just get sent to the screen here. Take the standard output of the ls command, and instead of printing it to the screen, send it to the grep command. Send it to the grep command's standard in. So we can kind of say, you run this command, and then whatever your output is, we're gonna take a physical cable, and we're gonna pipe your output into this other command. And then the output of grep is now going to come directly to us, to our terminal, as it's standard out. And what it's going to do is it's going to take all of this text, all of this text here. It's going to go line by line, and if it does not have all capitals read in that line, it'll just ignore it. And if it does, it'll print it out. So grep is sort of like a filtering command. We could grep for .json, and then we're only going to get that. If we grep for .js, we're going to get both this line and this line, right? Yes. Oh, no, again? I wonder why. Okay, so we're taking the standard output of this command and passing it to the standard input of this command. And if you haven't used grep before, I don't want to get too much into it. I can try and use a different command, but I'm going to write a series of node scripts here that are going to read information from standard in. They're going to modify that information, and they're going to send it to standard out. Okay? The first one I'm going to make is upcase.js. And I'm going to make this script an actual executable. So I'm actually going to rename it to just upcase. So I'm going to have a file in here called upcase, and I'm going to tell it that it is a node script. And let's see if this works. Okay, so I've now made an executable node script. So I don't have to say node upcase, but I could. But now we can talk about that in another time. I'm going to gloss over that. There's a module that talks about how to make scripts executable, so you can run them on run themselves instead of just running them with Node. But for now, I have this executable upcase script. And what it's going to do is it's going to read from standard in, and then it's going to uppercase all the text and then write that text to standard out. Okay, so let's do that. Node read standard in. I don't want to do it that way. Did I? Oh, again? All right. Change imports. I've never had this problem before. This is very unsettling. Was it? Oh, God.
Yep.
Okay. Maybe we will restart the projector. While I research this, I will let the projector restart.
So let's grab that.
Yeah, I just have to call it. I think you're like,
I would just set that right. So what's your
Come on, projector.
so let's go ahead and write.
yeah, putting the argument.
Should I
Yeah?
just grab my laptop and watch on Zoom? Or-
Yeah, I think it's coming up. It just flickered. But sorry, everyone.
I have to change this back to run it. Because you won't see the cursor.
Please hold. We are having technical difficulties.
So if you will, so I think this is just gonna find a particular thing, so it's like a sort of income. So if you go to your command, and then you open the tab, you type non-dom. And then in the next tab, you're gonna tab and you type non-race. You should be able to.
Oh wow, it's there, but it's just like super dim.
So please look at the current typing.
All right, can everybody see this now? So I've added some code here that says process standard in. If standard in is readable, that means something's being sent to standard in. We're gonna read a chunk of that, and we're gonna just write that to standard out. So we're gonna say standard out write whatever we were given, but we're gonna uppercase it. So we can see if I do ls-la and then I pipe this to upcase, it's gonna uppercase all that text and print it out. So we can do other things, right? We could cat the README file and we could pipe that to upcase, and it's gonna upcase all that text and it's gonna print that to standard out. So we could make another command here. I'm going to copy the upcase command to a reverse command. And in here, instead of just upcasing this chunk, I'm going to reverse all the characters in it. So I'll split it into an array, and then I'll reverse the array, and then I'll join it together.
It might need to be
Reverse chunk.
dots.
And then I will write the reverse chunk out. So if we were to cat the README but pass it to reverse, you can see we get back a reverse version. So ls -LA pipe to reverse will flip all those things around, right? So now we could also pipe this to upcase, and it'll flip it around, and then it'll uppercase it, right? So this is a lot of how the Unix ecosystem works, is we'll do things like, if I wanted to find a file in my home directory, let's say I want to go through all my, I just keep all my checked out cloned things in work. If I do find work, it's going to list every single file in that whole file system all the way down in all of its subdirectories. So I can say, okay, step 1, list every single file in this whole directory. This is going to be thousands of files. Then I can say pipe grep for any readme.markdown files. And so now it's printing out hundreds of readme markdown files as opposed to thousands of like all files, right? So this mechanism where we say get a command, or do step 1, and then step 2 is to do something else to this text that we're getting, and then step 3 is to do something else to this text. That series of A piped to B, piped to C is a real building block within the Unix ecosystem. So the way Node exposes this stuff to you is it lets you read the content that's being sent to standard in, and you can kind of do whatever you want to it and then write that to standard out. So if you wanted to make your own grep, you could write your own version of grep, which says like every time a line comes in, if it matches this, if it includes the text that I was given as an argument, then I'll print that. Otherwise, I'll just throw it on the floor and I'll ignore it, right? So we could write, I'll copy reverse into a, I'll just call it filter since it's sort of like that. So filter is going to take something from the arguments. It's going to take the first argument, which happens to be the third element in this array, right? And we're going to say, we'll call this our query. And just to make sure that this works, filter for readme. Okay, our query is readme, cool. So that works. So what we're going to do is we're going to say every time we read a chunk, if that chunk is not null and that chunk includes our query, then we'll forward that chunk along, otherwise we won't. So let's do ls-la pipe filter for readme. Oh, and this needs to be chunk. And maybe that didn't work. Let's see. I think the chunks don't necessarily come in as line by line, so I'm going to say if chunk is not null, then we're going to do chunk dot split by any new line characters, just so we're going line by line. And then we'll say if this line includes the query, then we'll send along just the line plus a new line character. There we go. Okay, so we've got ls-la, and we can say filter by anything like 279. And it's only going to print out lines that include the string that we were given. So this is sort of like a very simple grep. So this got more complicated than I intended it to be because I thought each chunk would come in line by line, but it actually just comes in an arbitrary chunk of text, and I'm breaking that up into lines, checking that if the line includes the thing you ultimately asked for us to query, filter by, then we'll send that line to standard out. So we could do two things, right? I could say ls-la filter by anything that contains R, and then filter again by anything that contains .js, right? And so we can kind of chain these things together. Shaken.
So you wrote a little node script to kind of do grep.
To kind of, yeah, do about the simplest grep you can imagine, yeah.
Sweet.
So how much of this do y'all feel like you're understanding? Can you give me like a 1 to 5? 5 being you fully understand it. Sweet. What can I get? Just like a 1 or a 5? Just like a 4? 4, cool. Okay. But this idea that each script, each process on a Unix machine has sort of an input and an output, and it also has this thing called an error output, which is nice. So so I have a couple more minutes, so I'll talk about that. So if we're looking at this, like we've got ls-la, and then we pipe this to upcase, and then we pipe it to filter for readme, right? We've got that going on, right? What if there was an error inside of upcase? And we wanted to know about that error, but we didn't want the reporting of that error to pollute this stream that we're making, right? We've got some data flowing through these programs, but we want some error output to happen. You can, at any point, you can also write to standard error. So I'll run this again, and we'll see upcase said this is an error twice. But if I were to like filter for error, this text is actually coming. This text is showing up in the same place as this other text, but they're actually two different streams. One is standard error. So here, if I were to pipe, let's actually back up for a second. And I'm going to go back to this example, right, where we're just we're doing an upcase and then we're doing a reverse, right? If I were to pipe this to /dev/null, not pipe, but rather redirect this to dev null, that means all the output from this series of scripts is actually just being thrown into a black hole of nothing, right? It's going nowhere. So we're not seeing any output, right? Because I told it to take all the output of reverse and instead of printing it to the screen, to just throw it in the trash, right? So now you'll see we're getting no output. But if there's any errors along the way, so we'll say upcase, had an error, we actually will see that printed to the screen because there's standard out and standard error, and they both come to your terminal. And so you can route them differently. So we can do something like, I want to put this content, so I'm going to check this out here. Let's do cat the tasks JSON file we were working with earlier, and we'll pipe it to reverse, and then we'll pipe it to upcase, and then we'll redirect that to messed up tasks.json, right? So this is our job, is to end up with this file containing this messed up version of our JSON file. So the job worked, but there were some errors reported to the screen. So that's why we have standard out and standard errors, so that you can still send the right data to the next script in the row or in the chain, but errors will still be reported to the user in their terminal.
Or could you like put the output of standard errors in logs so that the user doesn't
Yep.
see what's going on?
Yep, you can. And it's getting a little tricky then, but you can do like you can do that. And now all my errors. So standard out and standard in, standard out, and standard error are all can be referenced by these redirect directives to say redirect standard out here and standard error there. You can also redirect standard out into standard error and vice versa. So there's a bunch of cool piping that you can do where you can really picture all these programs that are running on a Unix box as like a piece of hardware in like an audio visual setup, right? I can take my VCR and I can pipe it into like a filter that's gonna flip the screen around, and then I pipe it into another filter that's gonna like take the audio out of that HDMI string and send it over here and give it some reverb and put it back together. And we can really wire up all these different modifiers by just knowing the cables that these scripts have, the inputs and yeah, exactly. The inputs and the outputs are all just piped together. So when you're thinking about how to solve a problem, you can consider, should I do it in one script or should I do it in a series of scripts that use each other? And really the Unix answer is to use a series of a bunch of small scripts that use each other. So if you were to ever want to like dive into the internals of how Git works, for example, Git is like 100 different scripts that all are used by each other and pipe things around to each other, and it's all kind of wired together in a very Unixy way. And as you're using the terminal, you'll notice that you're going to be learning things like, I need to find a file in my work directory, so I need to do a find some file here and grep for anything that has JSON on it, and maybe I also want to grep for something that doesn't include node modules. So now I'm doing an exclude of node modules. So now there's no node modules in here, and maybe I also want to make sure that this is talking about the Matrix app. And so you can see these are actual, so this is cool, right? These here, I don't know why I'm pointing, I'm recording this. These here are errors. These went to standard, these went to standard error. And this output, I don't know how I'm even doing that. What? These are, wow. I don't know how I'm doing that. Or that. But then these were the output, right? I found a file that had JSON that didn't have node modules but was part of Matrix, right? So as you get better at using Unix machines, you're going to be learning more and more commands that you can pipe together to do stuff, right? Cool. Lots of input and output. Yeah.
I will look into the different methods of piping that you were talking about, but in the standard setup, when you cat and then grep into or pipe into grep, is grep the one that's actually throwing the result onto the screen, or is like the result back
so
to cat?
if I cat, no, there's no going back.
Okay.
Yeah, so cat just produces this string,
Right.
and then if I give that to grep and I say look for anything that just has dash is really hard, but let's look for reading, right? Then grep is the one printing that out, and it's also adding red to this, which you can turn on and off, right? And then if I pipe it to grep again and I look for something with from, I'm getting the same output, but now from is the thing that was searched for. So the output is always coming from the last thing.
Okay. It's just changing where it got its input from.
Exactly.
Still the thing.
The input, the grep at the end got its input from the grep before it, right? Cool. And there's even cool things you can do, like fork your output to multiple commands and do like parallel processes or parallel tasks. Like it can get real complicated. But
I know if it was like the SD out is being passed back up, it's being passed back up, and the cat's like, oh, here's my result.
No. Unfortunately, it's a one-way system.
Okay.
Yeah. You can have two-way pipes, but I don't think the pipe that we have here in the terminal can be a two-way pipe.
Yeah.
Cool. All right, that's all the time we have. Thanks, everybody.
Thank you.